Okay, let's dive in. Picture this for a second. You're climbing out, just airborne, the ground's falling away, and suddenly you're immersed in this world of weather, aren't you? It can be absolutely stunning.
Oh, definitely.
But it's also, incredibly complex, always changing. And for pilots, weather isn't just the view, it's your entire operating environment, the thing you're constantly navigating, planning for.
It really tests your skills.
It really does.
Yeah.
You could almost say every flight is a kind of dialogue with the atmosphere. And, well, to have that conversation safely, efficiently, you absolutely need to understand its language, its structure, how it behaves.
Couldn't agree more. And that brings us straight into today's deep dive. We've tailored this specifically for you, especially if you're digging into those ATPL theory exams right now. We're using the source materials you provided, those notes and excerpts, focusing squarely on aviation meteorology. We're starting right at the beginning. The atmosphere itself and that benchmark model, the International Standard Atmosphere, or ISA. Yeah, our mission today is pretty clear. We're going to take all this information, this source material, and really boil it down to the absolute essentials, the facts, the figures, the core concepts that you really, really need to understand. Not just, memorize parrot fashion for the exams, though that helps too, but understanding builds that solid foundation for flying.
Right. We'll break down the atmosphere's structure, what it's made of, how things like temperature and pressure change as you go up, and how the ISA kind of gives us a baseline reference for all that.
And we'll definitely be repeating some of those key points. It might sound obvious, but repetition really helps things stick, especially when you're cramming for exams like the ATPLs. So expect to hear some things more than once.
Excellent. Okay, let's kick off. Why is meteorology such a massive part of pilot training? I mean, we all kind of know weather's important, but these notes really emphasize it. What's the fundamental reason pilots need to become, well, almost like amateur meteorologists?
It really just boils down to the absolute top priorities in aviation. Safety, number one, and then operational efficiency. The source defines meteorology pretty academically, doesn't it? The branch of science dealing with the Earth's atmosphere and the physical processes occurring in it.
Mm-hmm.
But for pilot, what that really means is being able to predict conditions, avoid hazards like turbulence or icing, fly the most efficient route, and make those critical gonna-go calls, or maybe deciding to divert mid-flight.
And the reason we have to understand it, not just react, is, well, the source nails it. Weather is the one big factor that man has no control over.
Yeah.
We can build these incredible flying machines, right? But we can't just switch off a thunderstorm or make fog disappear.
Exactly. You can't negotiate with a cumulonimbus cloud. You have to understand how the atmosphere works to anticipate what it might throw at you.
And the consequences not understanding?
Well,
they're laid out pretty starkly in those accident statistics you provided in the source material, tables 1 and 2.
Yeah, those tables are quite sobering, aren't they?
They really are.
Yeah.
Table 1 looks at UK transport aircraft accidents over 20 years. And if you filter out the minor ground stuff, it shows that weather influenced conditions in, about 28% of all accidents?
Almost a third. Yeah, that's a significant chunk. Think about that. Nearly 1 in 3 accidents linked directly to the atmospheric conditions.
It really makes you stop and think.
Yeah.
And Table 2 breaks it down further, showing what kind of weather is causing the trouble. It looks like wind and turbulence are the biggest culprits, right? Over 43% of those weather-influenced incidents.
That's right. They lead the pack. Followed pretty closely by visibility issues, think fog, low cloud, and then icing or snow. Each of those accounts for around 21% of the weather-related accidents.
So statistically, it's wind, turbulence, poor visibility, and ice. Those are the main atmospheric challenges pilots face most often.
Yes, but... And this is a really crucial distinction, especially for aspiring professional pilots. Look at the column for fatal accidents in Table 2. The picture changes dramatically. While wind and turbulence cause the most total weather incidents, when it's used to fatal accidents influenced by weather, visibility is overwhelmingly the dominant factor. It contributes to a staggering 66.7% of those outcomes.
Wow. 2/3. 2/3 of fatal weather accidents linked to visibility.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.